Hi everyone! In this video we'll cover the topic of nuclear decay. Nuclear decay is a spontaneous process that happens in the nucleus, where there are changes in the numbers of protons and neutrons. These nuclear changes are accompanied by the creation and emission of ionizing radiation, either from the nucleus or from the electron cloud, depending on the process. Why does nuclear decay occur? It happens when an unstable nucleus has an imbalance in the number of its nucleons and is trying to become more stable. It's important to note that nuclear decay does not occur with stable nuclei. Only unstable nuclei undergo nuclear decay, emit radiation, and therefore are called radioactive. Today we'll look at animations to try to visualize what is happening with the process of nuclear decay. We'll look at alpha decay, beta decay, positron emission, and electron capture. Alpha decay is the likely mode of nuclear decay for heavy nuclei, where Z is greater than 82. For these heavy elements, the instability arises because the strong nuclear force, which is short range, isn't strong enough to overcome the repulsion between the sheer number of protons in a large nucleus. In the alpha decay process, a cluster of 2 protons and 2 neutrons is spontaneously emitted from the nucleus in order to reduce both protons and neutrons in these heavy isotopes. This combination of nucleons is called an alpha particle and is equivalent to a helium-4 nucleus. Beta decay is the likely mode of nuclear decay when there are relatively too many neutrons in a nucleus. In order to try to achieve stability, a neutron converts to a proton, and as part of that process, a beta particle and an antineutrino are created in the nucleus and emitted. Positron emission is the likely mode of nuclear decay when there are relatively too many protons in a nucleus. In order to try to achieve stability, a proton converts to a neutron, and as part of that process, a positron and a neutrino are created in the nucleus and emitted. In our final example, we'll take a look at electron capture. Here, we're showing the electron cloud in addition to the nucleus because, as you'll see shortly, it's involved in the process. Electron capture occurs when there are relatively too many protons in the nucleus. The nucleus captures one of its own electrons from the 1s or 2s subshell. It then converts a proton to a neutron and ejects a neutrino from the nucleus. Because there is a gap or hole left behind due to the missing electron, a higher energy electron will drop down to fill it, creating an X-ray which is emitted from the electron cloud.